The Leave plan of room experts has found that utilizing our new $101 billion toy, it will be seemingly forever before that endeavor turns into a reality. On the slim chance that it goes as planned, the trip to Proxima B will require close to 20 years. So reasonably, it will be a couple of years before we can demand if there is sure life on that planet. The established solicitation of whether we are genuinely alone in this universe endures. The James Webb Telescope has found some amazingly humanesque things far away from Earth that lead us closer to the answer. Our mission for life beyond us has been uncontrolled throughout each human activity, so much so that we have a significant number of media works and hypotheses concerning this matter. Our marvel concerning our spot and misery in the universe has been consistent. It is imbued inside us to consistently look for a mate despite how partial like we may be. We may get increasingly closer to the answers we truly need. However, are they genuinely the answers we are searching for? Or are they simply more disturbing? Join us as we analyze the most recent discovery in the space of systems and planets on the journey to find something we probably won't be ready to see. Lights far away, subject matter experts have found what could be the most weighty discovery in history. Back in 2021, when the James Webb Space Telescope was scheduled to launch, a very interesting theoretical inquiry was raised about the abilities of our technology. The question was whether later on, our telescopes could detect artificial light on another planet, for example, Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was identified to be impeccably locked with an extremely permanent day side and night side, like our moon. A theoretical creative improvement on Proxima B could move power and energy from the day side to the night side using photovoltaic cells that make power from starlight. Therefore, in a paper with Manis Ving as one of the scientists, it was shown that a colossal concentration of the day side by solar chargers could be connected with future telescopes. Since JWST was further developed, it would allow us to extend our search for artificial lights on exoplanets like Proxima B. Now, the reality that the James Webb Space Telescope did precisely that in 2024, utilizing its higher awareness and greater extent of abilities, is momentous. The JWST could have found the lights we were looking for and perhaps flung us into another massive rush of human activity above all. We ought to dive into the universe of planets and exoplanets to sort out how this was indeed even conceivable. James Webb's mission investigates Proxima B and Proxima B's secrets. Starting from the beginning of recorded history, people have pondered the possibility of the universe, what we are, where we come from, and where we go. These are conventional yet remarkably troublesome requests that mankind has tried to answer. When we acquired awareness in the hour of excellent mechanical development, one considers whether we are any nearer to noting these solicitations. If you were to ask a philosopher, he could say we are still at level 0 of understanding ourselves in the universe. Anyway, ask a space master the same inquiry and watch him take full advantage of his energy as he races to let you know the latest revelation people have made about the universe using their smart devices. These instruments, albeit not given much thought by the customary public, are straightforwardly an impression of human activity itself. We now have the world readily accessible, and it's time we push forward and get the universe at our fingertips. One such strategy for doing that was determined by researchers and space specialists through the technology we tackle. A particular making of that technology is now responsible for the new discovery of what may be light on another planet light years away. Yes, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation considered out of the customs of human undertakings into space to address some ever-present questions. Are we alone? Who's out there? Where do we begin and where do we end? This infrared space science device has already begun watching out for these solicitations, notwithstanding the truth that at first you could get yourself asking what Proxima B is. Proxima Centauri B, or just Proxima B, is sometimes referred to as Alpha Centauri B. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths could befuddle you, but don't worry. This text will settle all your burning questions. Super-Earths are a class of planets that are more massive than Earth but lighter than ice giants like Neptune and Uranus. They are really one of a kind. They can be made of gas, rock, or even a mix of both, and their sizes can vary from twice the size of Earth to several times its mass. Regarding Proxima B, it is a super-Earth and an exoplanet, meaning that a planet orbits outside the nearby planetary group. The first possible evidence of an exoplanet was considered to be found as soon as 1917, although it produced little interest. However, confirmation came in 1992 with the first confirmed discovery, which left experts stunned. Another exoplanet, first identified in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These eminent discoveries are surrounding an M-type star. To understand the M-type star, you need to figure out the red dwarf. A red dwarf is the smallest type of star in the main sequence, hence the name. In the interconnecting region of the Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have incredibly low luminosity, and since luminosity is one of our main tools for planet detection, red dwarfs are not so easy to notice. These inconspicuous stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, thus getting their name. Also, regarding Proxima B, its mass is known to be comparable to 1.07 Earths. Curiously, it only requires 11.2 days to complete one orbit of its star compared to our 365.25 days. You can gauge the size of the star Proxima B is surrounding. Incredibly, under the evaluation of the whole electromagnetic range, the star has a total luminosity of as little as around 1.6% that of the Sun. Besides, in the visible light range, its sparkle appears to diminish more. It only shines 5 to 6% of the Sun's brightness, emitting an even lesser amount of light energy compared to the Sun. More than 85% of its radiated energy is infrared radiation, circling about 0.045 to 0.056 astronomical units from its star. Proxima B's discovery was reported back in 2016. You could inquire as to why Proxima B, with a million stars, planets, and universes, is of such focus. Well, there are a couple of reasons that add to the noticeable interest cosmologists have here. In particular, Proxima B is the closest known star to our Sun and, by definition, although 4.2 light-years is a big number to us Earthlings, in the grand scheme of the universe, it is a simple blip. Hence, why Proxima B, our nearest known star, is high up on the priority list right now. It is part of the triple star system called Alpha Centauri. Moreover, despite Proxima's luminosity being incredibly low, the system itself appears as one of the most brilliant celestial bodies in the night sky, just behind two others called Sirius and Copus. However, the most charming thing about Proxima Centauri B is that it could really be habitable as it falls within the habitable zone. The possible results surrounding the star are unending, and hence astronomers have taken on the task of exploring the depths and limits of the star's true potential. That's where the James Webb Space Telescope comes in. The four vital objectives of the JWST are to look for light from the first stars and galaxies that formed in the universe after the Big Bang, study the universe's formation and evolution, figure out star and planet formation, and focus on planetary systems and the origins of life. As the JWST continues its examination of the said exoplanet, we move closer to the summit of these missions, from looking for exoplanets to searching for extraterrestrial life. So what exactly is said, one could inquire. Considering that people have always been a curious species, inspecting and getting into literally everything that moves and doesn't move, it makes sense that a mission like SETI showed up on such a huge scale. Envision that God has coordinated an excellent, huge undertaking, but with a touch of gold. We are entrusted with being on the lookout for signals, more specifically electromagnetic whispers from human civilizations beyond anything we could ever imagine. SETI, short for the search for extraterrestrial intelligence, resembles the world's most high-stakes game of hide and seek, with our plan as the seeker and the vast universe as the seemingly endless hiding spot. It is one of those fields where researchers are like advanced Sherlocks, tuned into radio waves and scouring for that subtle, we are not alone signal. This cosmic sneaking around began in the 1960s. Frank Drake, a notable astrophysicist, was among the first to detect radio transmissions from the stars. It was a memorable moment, but no aliens showed up at his door. Now, anyway, as you might have guessed, Looking for something this enormous takes patience and can span many years of work. Sometimes, very few definitive alien signals have been found. Despite these efforts, the excitement continues to grow as the James Webb Space Telescope keeps on examining exoplanets like Proxima B. A whole field of hope is emerging. Anyway, will we stumble across real proof of extraterrestrial life? Or will we simply experience spooky signals just outside our ability to comprehend, giving us more questions than answers? The discovery of lights, in fact, could mark the next chapter of mankind's eternal pursuit, where curiosity and advancement blur into one massive, exciting space story. So let's continue looking, hoping to find confirmation that we are not truly alone. The discovery of lights from far-off exoplanets like those possibly seen on Proxima B could be a notable step toward answering one of humankind's most significant questions. Are we alone in the universe? As the Webb Space Telescope continues to examine the skies, its discoveries will undoubtedly spark more discussions, investigations, and maybe even challenges to our fundamental understanding of life, intelligence, and the nature of the universe. The implications of these discoveries extend far beyond simple curiosity. They carry the potential to reshape our philosophical and scientific frameworks. For example, if we were to confirm that Proxima B or another exoplanet harbors some form of life, it would require us to rethink our position in the universe. Could life somewhere else develop in ways similar to our own? Or would it present a completely new type of existence? Would it follow the same evolutionary paths? Or would its biology and consciousness challenge everything we know about life on Earth? Even if we don't find direct proof of intelligent life, the mere fact that we could detect artificial signals or lights from distant worlds would still have profound implications. It would mean that there are intelligent civilizations out there, at least theoretically capable of adapting their environments in ways that become detectable from our vantage point. This would confirm that intelligent life is not a rare anomaly, but perhaps a widespread outcome of specific conditions in the universe. Anyway, it's essential to remain grounded and cautious in the face of such discoveries. While the potential for finding life is exciting, it also raises the question, what happens next? How would we respond to the confirmation of extraterrestrial life? Would we approach it with respect, curiosity, and scientific thoroughness? Or would the discoveries spark panic, fear, or even political struggles? History has shown that mankind's reactions to new discoveries, particularly those that challenge deeply held beliefs, can be erratic. We should also consider the moral aspects of our curiosity. If we do find evidence of life, especially intelligent life, what does it mean for our responsibility as stewards of our own planet? What ethical considerations should guide our interactions with other forms of life, whether microbial or advanced? These are not questions that can be easily answered, and they will likely be a central part of the discussion as we venture further into the universe. Regardless, the search for life beyond Earth, led by instruments like the James Webb Space Telescope, represents a fascinating intersection of science, philosophy, and humanity's future. The next few years will likely be filled with more discoveries, more questions, and perhaps even answers that challenge everything we thought we knew about the universe and our place within it. The story of our search for extraterrestrial life is, in a sense, just beginning. With each new development, we are getting closer to a moment that could alter the course of humanity's history forever. As we continue to unravel the mysteries of space, the search for extraterrestrial life has sparked a deep sense of wonder and urgency in the scientific community. Instruments like the James Webb Space Telescope offer unprecedented capabilities to explore distant worlds, bringing us closer to answering profound questions that have persisted for millennia. One of the most exciting prospects is the possibility of finding life on exoplanets like Proxima B, a planet in the habitable zone of its star, Proxima Centauri. This star system, which is located just over 4 light-years away, is part of the Alpha Centauri group, making it one of the most studied regions in our quest to find alien life. While the search for extraterrestrial life often focuses on microbial organisms, the detection of artificial lights or signals could suggest the existence of intelligent civilizations. This would not only answer the age-old question of whether we are alone, but could also shift our understanding of the universe. As we advance technologically, our tools become more adept at picking up signs of life or activity, even from worlds that are light years away. These discoveries could pave the way for a new era in space exploration and even contact with alien civilizations. However, the search for extraterrestrial life also brings about ethical dilemmas. How would humanity respond if definitive evidence of alien intelligence were found? Would we treat them with respect and curiosity, or would we react with fear and uncertainty? The history of human exploration suggests that new discoveries often lead to unforeseen challenges, from cultural shocks to geopolitical tensions. Thus, the implications of finding life elsewhere are not only scientific, but also philosophical and moral. The discovery of artificial lights or signs of alien life would force us to confront deep questions about our place in the universe. It would push the boundaries of our understanding, challenging our notions of consciousness, intelligence, and life itself. In the end, our pursuit of answers may not only bring us closer to understanding the cosmos, but also reveal more about ourselves as a species, our values, and our future in an ever-expanding universe.